Okay, question 5. It says, given any two non-zero vectors a and b, show that a cross b squared is equal to mod a squared times mod b squared minus a dot b squared. Okay, well, the formula for a cross b is, so I'm going to say a cross b is equal to, let me get up the formula book to show you where it is. Okay, it's here. So a cross b is mod a mod b sine theta. So this is a b sine theta. But therefore a cross b squared is this squared, which is mod a squared mod b squared and sine squared theta. Okay, fine. And sine squared theta, so we want to think, how am I going to turn this into this? Well, we have a sine squared theta, but if you remember what's a dot b? Well, it's this, the scalar product. A dot b is mod a times mod b times cos theta. So if you, that's the only tricky bit of this question. Like, it's how can we do a proof where we're trying to turn a cross product into a dot product, where we're trying to turn a sine into a cos? Now, the fact that it's squared, we know that we can turn sine squared into cos squared. So this is actually equal to mod a squared mod b squared, and this sine squared is 1 minus cos squared theta. And if I multiply this out, I get a squared mod b squared times 1 minus this times cos squared minus this times this times cos squared theta. And so you can actually say here, but this is like a way to kind of add into the proof, but a b cos theta equals a dot b by definition. That's in the formula booklet. A dot b is equal to this. Yes, they're using v's and w's, but I can use a's and b's. So this, therefore, this a cross b squared is equal to this times this minus a dot b squared, because this, if this is a dot b, then this squared is a dot b squared, which is this. So I'm just going to write QED, which means I have proven what they asked me to show, or I have at least shown it. Okay, that's question 5.